Hey guys, it's Miss Roger here. I'm going to make this video to make it a little easier for you to be able to do your work at home. This video today is kind of a recap of what we did last Friday because I know there are a bunch of you not here. And then I posted some problems for you to do out of your book for this week. So still trying to figure out a way to get the work from you guys. So next week might be a little different. Just kind of bear with me this week and make sure you get your work done out of your book so that you're not behind for next week. And I still may be picking up this work as well. So make sure you get it done. It's not very many problems like we do in class, just a couple to do at home. So this is kind of a recap from last Friday. We talked about graphing quadratic inequalities. It's chapter 4-8 in your book. So we're just going to go over some of the problems we did in class then, just to kind of recap that. So the first problem that we did said to graph the inequality, and it says this is our inequality here. Let's see, undo that. So this is our inequality. Y is greater than x squared plus 2x plus 1. So we want to graph this inequality. So what you're going to do is just graph the regular quadratic function that you see here. We're going to graph x squared plus 2x plus 1. So to do that, we need to use the axis of symmetry equation to find the x coordinate of the vertex. If you remember, that's negative b over 2a. So stuff we've done before. So our b term in this case is 2. So negative 2 over 2 times our a term, which is 1, because 1 is being multiplied by the x squared. And this gives us negative 1. So x equals negative 1 is our axis of symmetry, but also negative 1 is the x coordinate of our vertex. So we just need to find the y coordinate. And to do that, we just take the negative 1 and substitute it back into our original equation. So if you take negative 1 and substitute it back in, you'll have negative 1 squared plus 2 times negative 1 plus 1. And this will equal, let's see, 0, right? If you were to work that out. So the y coordinate of our vertex is 0. So this right here is our vertex. Let's see if I can write this out on here. Vertex. Okay, so now we can come and graph that point. So here's our graph. We're going to go down negative 1 and up 0. So that point should be in here, if I can get it to draw. So that point is right here. So how do we get other points on our graph? We need to just substitute in other values of x, right? So if we come back to our other page, we can go ahead and erase this. Now we will just substitute in different values for x and then find the y coordinate. So another one that we could do would be to substitute in 0 for x. So if you have 0 that we're going to substitute in for x, and now we just need to find the y coordinate. So go back to your original equation, substitute in 0, 0 squared plus 2 times 0 plus 1 equals 1, right? So another coordinate on our graph is 0, 1. It's just like we put in 0 into the Coke machine and the Coke machine gave us 1 out. So we're going to go back to our graph and plot that. So we're going to go over 0 and up 1. Make sure you don't accidentally get your x and y coordinates backwards. Let's see if it'll let me do this here. There we go. Okay, so we have the point there on our graph, and we know because it's symmetric, we're going to have 1 on the other side, right? So then going back and looking at our original equation, it says that y is greater than, right? This is our original equation right here. So because it says greater than, we want to put a dashed line to indicate that it's not going to be greater than or equal to. If it was greater than or equal to, then we put a solid line on our graph. But because it says only greater than, we want to put a dashed line for our parabola. So here we're going to try to do a dashed line to indicate that greater than. Okay, so now we need to determine which part of our graph to shade in. And we're going to shade in the part of the graph that makes the statement true. So we need to test a point and substitute it back into our original equation and see if it makes the statement true. So the easiest point to do is the origin, the point 0, 0. When in this case, point 0, 0 lies outside of our parabola. So if we come back here, we can go ahead and erase this, and we are going to test point 0, 0. So that means we are going to take 0 for our y and substitute it back in, and 0 for our x and substitute it back in. So if y is 0, we have 0 is greater than 0 squared, it's supposed to be a squared, plus 2 times 0 plus 1. So we get 0 is greater than 1. That is not true, right? Not true. True. So, looking at your equation, we plugged in 0, 0, right? So, like we said, 0, 0 is outside the graph. And we said that that was not true. So, that means everything with inside the graph is going to be true. So, if you were to take any of the points located inside the parabola and do what we just did, it'll make the statement true. If you take any coordinates outside of the parabola, it will make the statement not true. So let's try another problem that shows this. So I'm going to go ahead and erase this, and we will try another problem. So let's go ahead and get our graph here. If y'all have got this, okay. And we will go ahead and erase all of this. And let's try another problem. So if you have y is less than or equal to x squared plus 2x plus 4. Okay, without even doing anything, you should be able to tell that this graph is going to open up because your a term is positive. And in this case, you're going to have a solid line for your graph because it says less than or equal to. So that indicates you're going to put a solid line for your graph. But we're still going to graph it the same way we just did. So we need to find the x-coordinate of the vertex, and we do that by doing the negative b over 2a. So that is negative 2 over 2 times 1, right? Because our a term is 1. And we get negative 1 again. So to find the y-coordinate of the vertex, let's see. So we have the x-coordinate, and now we need the y-coordinate. We take negative 1 and substitute it back in. So you have negative 1 squared plus 2 times negative 1 plus 4. And this comes out to equal 3. So the y-coordinate of the vertex is 3. So now we can go back to our graph and plot this vertex. This is our vertex. So -1, down -1, up 3 should be, let's see, right in here, if it will let me draw it. Here we go. So we need to find more points on our graph, and we do that by substituting in more values for x. So in this case, we could do point 0 for our x coordinate. So let's go ahead and erase this. So now we are going to substitute in 0 for our x, and we're going to try to find the value of y. So if we substitute in 0, 0 squared plus 2 times 0 plus 4 gives us 4, right? So the y coordinate in this case is 4. So we can go plot that point. So up 4 should be right in here. If I can make it do it, let's see. Yes, and because it's symmetric, it should have a point on the other side. Right there. And we said in this case it's going to have a solid line because it says less than or equal to. So we can go ahead and draw our parabola with a solid line. Let's try again. A solid line. And now we want to figure out which part of the graph we're going to shade in, and we need to do that for the part of the graph that is true. So we need to test a point. In this case, we can try to test the point at the origin again. So we can come back here. We can erase this. And we want to test the point 0, 0. And we want to see if it makes this original inequality true. So if we substitute in 0 for our y and 0 for x, we get that 0 is less than or equal to 4. And this time, this is true, right? Because 0 is less than or equal to 4. So we tested the point at the origin, and it made the statement true. So the origin lies outside of the parabola. So this means everything, all of these points outside of the parabola are true. So you want to shade in everything outside of the parabola. And everything that's inside the parabola would not make the statement true. So those are just some examples for you to follow. I want you to try to do the questions that I posted and let me know if you have any questions. Thanks, guys.